Good morning, everyone. Welcome to our webinar, The End of an Era, Transitioning Beyond 2G and 3G. My name is Amina Christensen, and I am the CMO at Comfort. And we have an exciting session ahead of us as we delve into the transformative landscape of IoT connectivity. So the global tech scene is evolving rapidly, and today we'll explore the imminent shifts from 2G and 3G networks towards the rise of 4G and 5G technologies. This marks a crucial turning point in IoT connectivity, and we are thrilled to have with us today experts that will guide us through this transformative period. So at this end of this webinar, we will have a Q&A session. So please feel free to send your questions as we go along, and we'll be dedicating time to address them and delve deeper into the discussions with our speakers. So now, before we jump into the details of the webinar, let me introduce our keynote speakers for today. So we are honored to have with us Marcus Gronstad, Senior IoT Solution Specialist from Comfort, and Daniel Barati, Engineer and Manager at BikeFinder. So Marcus will be our first keynote speaker, and he will bring a wealth of experience in IoT technology, and at Comfort has been instrumental in navigating the complexities of network transitions. So Marcus, please go ahead. The floor is yours.
Well, thank you so much for that introduction, Amina, and thanks to everyone joining on this webinar. I will share some of the details and insights around the topic of 2G and 3G network closure, or sunset as the industry term that we usually refer to it. So what I will go through in this presentation is a technology overview of the present and future mobile technologies, some background and status around the 2G and 3G sunset, some more details around the new replacement technologies for 4G and 5G, and finally, a few words on the migration and what to consider in that process. Before continuing, I want to use a few minutes for an introduction of Comfort and what we deliver. We are a global mobile operator based in Norway, where we focus solely on delivering connectivity to IoT solutions, and we are specialists on this. With our SIM cards and connectivity solution from us, we can give access to over 750 mobile networks globally across 190 countries, where we work with all available mobile technologies, from the now outgoing 2G, 3G to the newer 4G, 5G with the low power wide area technologies, Narrowband IoT and LTE. We are part of the Wireless Logic Group, where we together with them are today serving over 10 million SIM cards and connections globally. Today, we are involved in projects with IoT connectivity across all kinds of verticals. To mention some of them, as an example, in the energy sector, we have automated meter reading systems. We have remote maintenance and monitoring in energy and grid sector, and EV charging. In retail, we have payment terminals and tracking of goods, vehicles, animals, and people within logistics. Alarm and video surveillance is a few examples within security. Common for many of these scenarios and projects that we have been involved in is that they have either started out with a 2G, 3G connectivity that has been rolled out in massive volumes, and they will need to migrate to newer solutions. Or they are starting today with new products on newer technologies and need to make a choice of a future-proof technology from the start. If we start out by looking historically at the technologies being used. From the 1980s, we had the first generation of mobile technology, and we have seen a new generation being introduced every decade in the industry. The 2G technology came to market in the 90s, with being the first digital standard, also introduced the support for packet data and SMS. So until today, it's been a long-living technology that has been ideal for many M2M and IoT use cases, being both affordable and globally available. Later on, 3G came that had some improvements on both existing technology and slightly higher data rates. But it was with the 4G that we had a full new IP-based architecture with significant higher data rates, opening up for many new use cases, and also with new voice services launched. In the 2020s now, we have later on had the 5G been introduced, where we see the first connections are being delivered in conjunction with the existing 4G network architecture. Later on, we'll now see operators deploy new 5G core architectures that will support new kind of services. Also, here recently, the last years, the new IoT LPWA or low power wide area technologies, narrowband IoT, and LTM was introduced that we will go further into details in this presentation. But first let's look at the background and sunsetting or closing down of the 2G and 3G networks. All over the globe, the planning of the 2G and 3G sunset has started. And in many regions, the process is already ongoing. Traditionally, 3G is shut down first because most of the devices out there is capable of utilizing an older technology once you support 3G, either by already having support for 4G or having a 2G support. While we see that there is still a lot of only 2G compatible M2M devices still widely in use. So why are the operators doing this? To start out with, the radio frequency spectrum is a limited and shared and costly resource. The newer technologies on 4G and 5G are more spectrum effective and then will give higher bandwidth, lower latency, and also important more space for more users. This more modern architecture and infrastructure supports also better and more effective operations of the mobile networks for us as the operators. It also gives us further opportunities to develop new service. The actual ongoing process is where we are moving frequencies, so-called refarming, from 2G, 3G to 4G, 5G. In Norway, a good place to keep updated on the details around this, like which frequency bands is allocated to which mobile operator on which technology, is an overview Nkom has created, the National Communication Authority, called Frekvenskompasset. Here's a table on it from the right side that shows the distribution of the various technologies and how the operators utilize them. As we see in this example, most of the frequency bands today is used for either 4G or 5G already. So the 2G, 3G closure is actually happening. USA has already more or less completed the process. And for Europe, we see that the year 2025 is announced as a closure date for many operators. If you look specific for the Nordics, we see that 3G is closed down already for all operators. And 2G is announced to be closed for most of the operators, at least in Norway, Sweden, and Finland. We as an operator are collecting this kind of information through partnerships with all the other operators and from also various other resources. And we work closely with all of our customers to ensure that we can maintain these services through all of the network changes that are happening. We have a full list of the various network operators and countries with their announced dates for shutting off 2G and 3G on our websites, and we can provide a direct link to it after this webinar. Lately, there has also been some uncertainty about the dates in Europe due to regulations around the emergency call feature that cars are equipped with. Many of these are on 2G only today. So we don't know yet how that will affect these closure dates, really. But I would not recommend anyone delaying their migration path from 2G to 3G anyway, because it is in fact happening. So when migrating from 2G and 3G, there is a variety of different technologies available to choose from today. And we also see new ones on 5G coming on. Both LTM and narrowband IoT can be seen as direct replacement technologies for 2G. They are launched and available on 4G and then further standardized on 5G. So they will be long-living technologies. Pure ordinary 4G will be with us for many more years. There exist many different devices and equipment available with different feature and speed classes today. ranging from the simplest Cat1 that are often used in IoT applications with bandwidths of 5 to 10 megabit per second. The Cat1bis standard is also a new one that simplifies design with simpler modems that only needs one antenna. Cat4 is the highest speed class before LTE Advanced and MIMO antenna solutions that will give you speeds of 50 to 150 megabit per second. All of these will typically cover most IoT cases today. With 5G, we have also some new standards coming in. We have NR, or new radio, for the really high bandwidths. And then we have the new RedCap, or NR Lite standard, that in the future will replace lower 4G LTE speed classes, and a technology that can be relevant in closed 5G private networks now from the start. So to address more of the details of the new LPWA replacement technologies and the relationship to the 5G standard. 5G, as defined, is built on 3 different pillars, as seen on the right side illustrated here. We have the EMBB, or Enhanced Mobile Broadband, that we see today on mobile phones and fiber replacements, giving the real high speeds. We have the URLLC, Ultra Reliable Low Latency Communications, that address some of the cases with critical networks with low latency requirements. Then we have the MMTC, Massive Machine Type Communication, that is defined to be delivered by Narrowband IoT and LTM, and addresses the real 5G IoT with ultra high density, ultra low energy, and deep coverage functionality. Both NB-IoT and LTM are technologies with different features and functionality, but they complement each other. Usually you have devices that can support both technologies, but they will work independently from each other. And it will be up to the user application to select which technology to use in your product. Also, some modules comes with 2G fallback in addition that can be valuable during this transition phase where we still have 2G in some markets. Obviously, that will then be without the power saving functions and the new functions of these technologies. NB-IoT has the lowest data rates of these 2 technologies, but also the lowest power consumption and the deepest coverage, meaning that it's good to maintain a cellular connectivity in real challenging coverage environments. LTM has slightly higher data rate, but also have capabilities for low power consumption, deep coverage. It also has support for SMS, limited voice support, and a support for mobility, meaning that you can maintain a data connection when you are mobile or between base stations. One thing to note is that in parallel to the technology development in the mobile networks, is that there has also been an important development on the SIM cards. Today, we see that the majority of OEMs utilize the embedded SIM or eSIM, or also called chip SIM, that's a soldered component on the device rather than the interchangeable plastic SIMs. We will also now start to see modules supporting iSIM or integrated SIM, where the SIM card functionality is moved into the chipset of the device, eliminating the need of a SIM card as an external component. The GSMA compliant version of iSIM is still only available on a few certified models, but we expect more to follow within this year. Across all of these SIM types, we also have the EOICC standard that makes it possible to switch operators and download SIM profiles in a standardized way among operators. So when considering new devices, it will also today be more important to take into account the SIM card functionality and form factor to create a future-proof solution. So finally, I would like to give some words and tips that based on experience from different projects that would be valuable to look into when migrating from 2G to 3G. To start out with, you should analyze if your existing product can be upgraded. Perhaps it has a separate communication device or a communication board where the vendor has a newer generation available. If it's not directly replaceable, maybe the modem vendor has a compatible modem type with newer technology so that a redesign can keep it to a minimum. However, often a redesign project can be an opportunity to look at a wider technology uplift, where new solutions can be looked into around management, security, communication protocols, and so on. Maybe your product today only utilizes SMS, and your next generation product can take use of a data bearer instead. There are several options today on replacement technologies, as we have seen. So it will be important to identify all of your technical requirements that your product and solution has before choosing the right technology for connectivity. You'll also need to inspect which technologies and coverage is available for you where you are deploying the solution. That's something that your IoT communication provider should be able to help you with. It could also be wise to support several LPWA technology, at least if you are deploying your solution globally. Also, the support for the technology is important to have right in the market where you produce your product, if that's different than where you are deploying it, so that you are able to do factory acceptance tests of the product before you are shipping it out to the customers. As you also seen, SIM card types is something that maybe has not been taught so much on previously, but now there are choices about various industrial qualities, functionality, and also the UICC solution, so that you can be prepared to switch operator or download another profile in the future. Recently, we had a customer case where we had a customer facing a 2G shutdown in one specific market. They had rolled out several hundred of their product, supporting both 2G and LTE in that market. However, the mobile operator or network they had access to had only support for 2G that was faced to be shut down. The alternative network provider was not able for them to use with their current SIM profile. So we helped out this customer with the UICC solution, where we downloaded a new SIM profile for all of their devices, making them available to connect to the other network with LTE connectivity. So that's something that shows the strength of using these new technologies actually, where the customer didn't need to go out to site on all of these places and actually replace either the SIM card or the product. So that concludes the end of my part. As an IoT connectivity provider, we are closely involved in many different projects where we can support you with the topics I went through today. So please reach out to us if you want to follow up on some of these areas or have specific projects that could be relevant to look at. Then it's back to you, Amina.
Thank you, Marcus, and thank you very much for your interesting presentation and valuable insights. We can see that your expertise has provided us with a deeper understanding of the evolving tech landscape and the strategic considerations surrounding the transition from 2G and 3G. So we really appreciate your contribution today. And now let me introduce our next speaker, Daniel Barati from BikeFinder. Daniel is an engineer manager and has an extensive expertise in engineering and product development. And he has played a crucial role in BikeFinder's innovative approach to utilizing next generation network technologies. So please, Daniel, the floor is yours.
Thank you, Amina. Thanks for that introduction. So as you said, I'm an engineering manager here at BikeFinder. And let me just share my screen here. Yeah. I want to thank you for the opportunity to speak here today and share our BikeFinder journey on how we transition from 2G in our product. This is what we're going to talk about. I will shortly introduce BikeFinder. Then we're going to speak about what we do in the market that we operate in, the BikeFinder user experience as it was with our previous product, and how we transitioned to our second generation product. And then a few words about testing the solution and the coverage. So BikeFinder is a bicycle anti-theft tracking solution, and we aim to have global coverage. The hardware, it fits all bikes, and it has a patented expansion lock. So it is installed into the handlebar and locked into place. And since we started selling this, our product, we have a proven track record with more than 75% of all bikes that have BikeFinder installed. They were either returned or covered. And since we've started, or since we sold this solution since 2019, we have customers now in more than 30 countries, and we have a strategic presence in 6 of them. And bike theft is a growing social or socioeconomical issue across the globe. And I just wanted to present a few facts here. So as you see from this slide, we are transitioning more into electric bikes. For instance, nearly 50% of the bikes sold in Belgium are now electric. And with that, you know, electric cars are more expensive than traditional bikes. With regards to theft, this results in a big problem. So just a few facts about bike theft here. So 30 to 40%, 1,000 of the bikes reported stolen in Belgium. There are 30 to 40,000 bikes, and a project that tracks bicycle theft in the US has concluded that over 2 million bikes are stolen annually there. So this is the market that we operate in. The tracker is activated and operated through the BikeFinder app. So we allow for multiple trackers. You would need a subscription to be activated, and you can opt in for an insurance or not. But our included our included insurance is a market-leading one. In the app, as you can see in the picture, you can see where your bike is located, and you can see previous locations, check the battery level, and so on. And if the bike gets stolen, the theft can be reported to us directly in the app. So the user will then be contacted by BikeFinder to initiate the process of locating where the bike is, and the process with talking to the police. When the time of retrieval comes, when you want to find the bike, so of course you see the GPS positions, but when you want to find it near field, you will use the integrated Bluetooth system. So the app will give accurate close range location of the bike. And of course, if you've purchased insurance together with the subscription, if the tracker isn't found within 2 weeks by BikeFinder, there will be an insurance case on that. So here is our first generation tracker, which we started selling in 2019. So as you see in this picture on the right side, the woman here installs it into the bike handle. There's a very easy installation with only 2 screws, and the screwdriver that can be used on this device is given in the box. And it has an expansion mechanism that locks it into place. The weight is 52 grams, so it's not noticeable, and it's waterproof, so you can use it in any weather conditions. So this is actually designed in Stavanger, so it should be prepared for the rainiest environments. And then we aim to have a global coverage. So it has an inbuilt eSIM, GPS antenna, and the Bluetooth data communication, as I mentioned. So this was the product that supported or was driven by the GSM network. And then we started transitioning from 2G. So in 2019, we saw the need for, or we wanted to be a bit more modular in our design that we were previously. We wanted to expand our technology stack to also include Wi-Fi. So many people may not know this, but Wi-Fi or scanned Wi-Fi signals can actually help with localization. So we wanted to have one more foot to stand on, so to speak, and wanted to include Wi-Fi in our tech stack. And with this new product, we also wanted to be connected to Cat-M1 and the NB-IoT network. So, of course, we were greatly motivated by the shutdown of the 2G network. But we saw that with these technologies, we would have a good network access in areas that are difficult to reach. So these technologies are for IoT products. And the combination of both of these was important for us because different countries prioritize the adoption of these differently. So another thing that we experienced was that with 2G, many years in the market has led to cheap and efficient hardware solutions, which is good. But when you are an early adapter of Cat-M1 and NB-IoT, we experienced that you should expect more cost when transitioning away from 2G. Of course, in that period, we were hit with lack of components. That was, of course, during the COVID years. So that may have kind of influenced our experience as well. Another thing that we experienced was there are more bands than what we were used to with 2G. You may face more challenges during the antenna development phase. The band frequency ranges are a bit more narrow compared to 2G. So what we tried to do was to develop our antenna with a more generalistic approach essentially going wide range to try to cover all of the bands. Also, if you incorporate both Cat-M1 and the NB-IoT into your product, you need to think about how you want to prioritize those. So depending on your location, you might want to have one factory setting, or you want to maybe change the configuration while in market with the product. And then a few benefits when you're transitioning away from 2G. So with what we transition to, the Cat-M1 and NB-IoT, we see that battery life is increased, and that's because we are reducing the radio communication between the device and network. And the device can go more into sleep and listen less to the network, which of course affects the battery life. And a hypothesis that we have, we've not confirmed this yet, but especially with Cat-M1, we want to see if this technology or positioning using cut M1 signals can help us compared to 2G. So using third-party APIs, you can always look up cell tower stations and get the coordinates. And what we've seen traditionally with 2G is that you get horrible accuracy, typically within a kilometer or two. But since the cut M1 signals they cover less range, we hope to see that we are able to get better accuracy when positioning using the base stations. But of course, we need more time in the market to conclude on anything here. But that's our hypothesis. Yeah. So a few words about testing. So in our experience, the lab testing is very, very hard. We experienced that no theory or lab can simulate real life scenarios. So we needed to conduct a lot of in-field testing while developing the second generation tracker. So we've had employees, friends, and even board members to test our product any chance that they could. And we've been testing during development in Europe, North America, South America, and Asia. And there was actually one example of we had a concern about the specific type of sim that we evaluated in the UK. And our CEO, while on a business trip in London, she actually went out in the streets of Soho and waved around a tracker to test the signals. Yeah, so testing was found to be very crucial. So this is the final product that uses LTM and NB-IoT. It is modular and it uses both cut M1 and NB-IoT in combination for maximum coverage. A different approach was needed to be taken with the antenna design, as I mentioned, and yeah, in-field testing was found to be crucial. And we released this product actually last year, and we've been selling it in select markets where where essentially 2G is shutting down faster. Yeah, that was it from my side. Now, thank you. Back to you, Amina.
Thank you, Daniel, for a very valuable contribution and shedding light on the intricacies and challenges of network transitions, especially through the compelling case study with the bike finder. So now to sum up today's sessions, we've had a great deep dive into the evolving tech landscape, exploring the significant shift from 2G, 3G to 4G, 5G. So we've gained insights into the strategic considerations, industry impacts, migration methodologies, and real-world experience from Bike Finder. So before we open up the floor for the Q&A session, I encourage our attendees to share their questions. Daniel and Marcus are here to help and to provide additional clarity and insights into any queries you may have. So please feel free to type your questions in the Q&A box and we'll address them shortly. Thank you. All right, well, let's see. No, so many questions. So I can maybe start asking Daniel a question regarding Bike Finder. Danielle, in which countries is the theft insurance offered at Bikefinder?
Yeah. So as I said, we are in a lot of countries. The insurance, it's offered in Scandinavia, of course, the Scandinavian countries, and UK and Germany. That's where we've kind of those are the markets that we've selected to go out strategically, and we've partnered up with Trygg in the Scandinavia, and then Hepster in Germany, and Cycler in UK.
And a question linked to our topic today, how have you experienced the new technologies, NB-IoT and LTM?
We've had very good experiences. The coverage is very good. Of course, we were a bit concerned, as these are kind of new technologies, and while 2G has been in the market for a long time, these technologies are kind of still in the adoption process. Especially some places in the world, they've not been rolled out yet, but in most Western countries, both of them are rolled out. So our experience has been very good until now.
Good to hear. And now a question to you, Marcus. We hear a lot about satellite communication as one of the newest technologies for IoT connectivity. So my question to you is, do you think that satellite communication is a good alternative to 2G and 3G?
Yeah, that's a quite relevant question now, Amina. As we have seen recent development within the 5G standard, where we have something called NTN, or a non-terrestrial network, that addresses the satellite-based communication in conjunction with cellular technology. So already from this year, we have seen that there will be coming modules into the market that both support Narrowband IoT and LTM, and in addition also this NTN standard, or satellite-based technology. So that's something that very well will fulfill the gap where in quite rural areas where you don't have access to any cellular network. So I believe that we will start to see more commercial products being rolled out on that later this year.
Exciting times ahead. Which of the IoT technologies do you see has the biggest adoption today?
I think we see a lot of interest for all of them today, especially now lately, a lot related to the normal LTE Cat 1 or Cat 1 bis, where we see that the modules are getting quite affordable. And you have a global footprint there with where you can use it on all existing 4G networks that exists today. Then we also see a lot of products out there globally today on LTE-M. We see that maybe that has a higher roaming footprint than NB-IoT today. But also several products are using the same functionality as Daniel and Bikefinder does, where they utilize both NB-IoT and LTE-M to really maximize their footprint and be able to connect wherever that technology is available.
Thank you. So this is now the last chance to ask a question. Okay, well then we might have a wrap up now. So I just want to thank everyone for joining today's webinar, the end of an era transitioning beyond 2G and 3G. So your engagement made this session incredibly valuable, and I am very thankful to both Marcus and Daniel for their insightful contributions. So your expertise shed light on the crucial aspects of transitioning from 2G, 3G networks and more advanced technologies. I would like to let you know that the recording and the slides will be soon available. We'll email you the link, and we will also email you the link to the table with all the 2G and 3G shutdowns and the dates. The webinar will be also accessible on our website for on-demand viewing. So please feel free to revisit the content and share it with your colleagues and your peers. If you have any questions or thoughts about the sessions, we're here to dive deeper. So just send us your questions to Marcus, to Daniel, or to me. My email address is amina@comfort.no. So I would like just to thank everyone for their participation and stay connected for more insights and updates. So have a great day, everyone. Bye-bye.